Good evening, ladies and gentlemen, and welcome back to the European Space Operations Center, ESA, here in Darmstadt, Germany. I'm Monica Jones, and I have the great pleasure to guide you through this short but very important evening program. Been an exciting day, and it's really good to see you all still here. Now, as you remember, this morning we witnessed and we broadcast the launch and the early flight of ExoMars, the very first joint space mission to Mars of the European Space Agency, ESA, together with the Russian Space Agency, Roscosmos. And at this point, I would like to say a very special hello to the Russian Space Operations Center, ZUP, in Moscow. I believe quite a few people there who are involved in this project are actually watching us right now. So, good to have you here with us. Now then, some 12 hours ago, it has been a long day. We saw ExoMars lift off successfully. Throughout the day, we've witnessed a number of very crucial maneuvers and procedures to bring the satellite into the right trajectory to Mars. We had some very interesting talks here on stage. A busy day, but you know what? Why am I telling you all this? We have actually gathered some images of the day's event, so let's start by looking at them now.
Первой ступени.
So this is what happened until now, the very important bits. But this evening, we have a very, very crucial moment as well. That's why we're here. We expect to receive the very first signal, autonomous signal there after separation, coming to us here to the main control room, which is just around the corner here at ESA. And if we take a look at the main control room, the screen you see there on the far left, that's the one that all eyes will be glued on. This is where at 22:29 approximately, we will expect to see the signal, and then we can say that ExoMars is truly en route to Mars. So we still have a few minutes to go, but this is where we will keep our eyes. Now, the Russian launch provider in Baikonur in Kazakhstan controlled everything right up to separation, so that was as long as the satellite was attached to the breeze upper stage. About an hour ago, ExoMars was separated from the breeze. So let's find out what's the latest here. Let's cross over again to the main control room to Michel Denis. He is ESA's ExoMars flight director, and he can tell us a bit more about the current status. Michel, it's good to see you here. Tell me, by now, you should have received a confirmation of the separation from Russia. Where exactly are we up to?
Well, actually, we have got good news. We received first a vocal confirmation that the separation was happening and looked nominal. And half an hour later, we have received the fax giving the preliminary departure parameters. Flight Dynamics have analyzed it and propagated it. And the orbit looks good. The launch is nominal. So we are on our way to Mars.
Okay, brilliant. That's wonderful. Don't know if you can hear it. People are applauding. That's great. Now that we know where the satellite is, what's the next step?
Well, the next important step is, of course, the acquisition of signal from over the ground station in Malindi. This should happen in about 14 minutes from now. The onboard automatic sequence is running and will soon switch on the communication system. So in 14 minutes, we should see a signal on the screen up there and start receiving telemetry on our control system if a spacecraft has done all its job properly.
Is there anything that still needs to be done, like small corrections? I mean, the separation here happened far out in space. How do you know it all worked the way it should?
The colleagues from Flight Dynamics will confirm this in the next few hours, but at the moment there seems no need for correction.
Okay, and what happens, I think the breeze upper stage, it's separated, but it's still following the satellite, right? There is a certain system that will ensure that nothing will happen to any planets that happen to be in the way.
Yes, for planetary protection, the breeze, which is of course under control of the Russian colleagues, is then deflected such that it doesn't impact any planet and of course doesn't impact the TGO.
Okay, so we even keep an eye on that, planetary protection during this mission. Well, Michel, Denis, thank you so much for the moment. Of course, we'll catch up with you later again when we expect to get that signal. Okay, thank you so much.
Thank you.
So, ladies and gentlemen, that was a very, very important step in this mission. Satellite's been released. It is on the right track to Mars, and ESA has taken control. Okay, we still have a few minutes, as we just heard. In the meantime, let's just recap what this mission is about and what its three main objectives are. First of all, the orbiter will become the new communications satellite around Mars, ensuring that all future landers and rovers will be able to communicate with the Earth. Then the lander itself, it will test the latest landing technology under very, very severe circumstances, as we heard earlier today. And both the orbiter and the lander will examine the Martian atmosphere. They will search for water, for methane, for other trace gases, and they will also keep a very close eye on weather conditions on Mars. So this is a very busy, a very important mission, certainly, with lots of interesting data and science. And science is actually the cue here. I'd like to talk a bit more about that, and I've got just the right person for it. Mark McCaughrean, Senior Advisor to ESA's Director of Science. Mark, welcome on stage.
Good evening, Monica. Good evening, everybody.
Yes, don't hesitate. Don't you hesitate. Mark, I know you always have a very specific view on things, and I'd like to know your very personal take on ExoMars.
It's an amazing first step for us in Europe. It's been 13 years since we went to Mars with Mars Express. So it's an amazing first step along the rest of the path. We're going now with this amazing machine up here with the lander and with the orbiter. And the next mission is the rover to start digging under the surface and look further in. And of course, the long-term aim for our program is bringing samples back from Mars. Beyond that, of course, it's always about humans. When will humans go to Mars?
Right.
Will we do that in the next 20, 30 years? That's sort of always been out there. And what's the purpose? Is it for science? Is it for exploration? Is it for inspiration? Or as some would say, is it to save the human race by getting us to be a multi-planet species?
Now, of course, we heard a lot about the search for life on something other than Earth. What if we do find traces of life? I mean, what does this mean?
Well, you know, we know that there's life on this planet, we think. Intelligent life, maybe. But is life a universal phenomenon? Has it actually existed, been generated elsewhere in the universe? And the first place we can look is our own solar system. We can look at planets which are rather similar to ours. And of course, we're doing that on Mars. It's the planet which has the most similarity long-term historically. But also, there's this sort of weird thing we haven't talked about at all today, is the possibility that the life on Mars is the same as the life on Earth, because there's crosstalk between the terrestrial planets in the sense that asteroids, big objects, hit our planets, spew material into space. I mean, we're spending a lot of money going to Mars, but many in the people in this room, the science community and the engineering community, will already have held Mars rocks in their hands.
And they found them here on Earth.
They found them here on Earth, exactly. And there's crosstalk the other way. So there would be others who would say, well, okay, if we find life on Mars, does that really prove that it's unique? There may be other places in the solar system, the liquid hydrocarbon oceans of Titan, or underneath the icy crusts of the moons going around Jupiter and Saturn. And beyond that, we have new observatories, new satellites, which are looking for traces of life around other planets, around other stars. So it's a universal question, and finding it on Mars will be amazing.
But of course, what is really amazing, if we find still traces of Mars, then it would have survived 3 billion years.
Well, we have very, very ancient life forms here on the Earth, which have just They found their ecological niche very early on, and they haven't changed since. Why would they if there's no pressure on them to change? So if there is an ecological niche on Mars which has persisted under the surface, they could be there.
Okay, apart from this very obvious science and the data, the proof that we could eventually find there, these traces of life, what do you think, or what do you hope, what impact can a mission like ExoMars have on our society, on our world?
Well, again, there is this idea that, you know, if there was a major asteroid impact on the Earth or a major supervolcano event, that humankind is vulnerable. And it is on long-term scales. We know of these big events in the past. But I think it's a little bit premature for us to say it's time to jump this planet. You know, even if we send 1 million people to Mars, that leaves 99.99% living on the one planet we know does work for us in the solar system, which is right here. And, you know, I don't want to bring too much of a downer on proceedings, but we have problems on this Earth. We have problems with global climate change, we have problems with the resources, with energy, and we need to solve those problems for the human race.
We need clever people who can do that.
We need clever people, and the way that we can, I think, play a role, a key role from these amazing missions is inspiration.
Right.
We need kids to come into science, technology, engineering, and maths. We need them to know that 2 + 2 = 4, regardless of which government's in power currently. We need that. We need people who are inspired by what we're doing, the cool stuff we're doing today, because this is where we live. We may have a future elsewhere in the universe, but today, this is where we are.
And of course, science always implies that it actually works. But science also has to live, and everybody knows that, with failure. How can you inspire with failure?
Well, it seems weird, right? But again, everything that we do in the science program and exploration has to be close to the edge. If it's not that close to the edge that we're able to, you know, see over the edge and take the risk of seeing over the edge, then maybe we're not doing the most exciting stuff. And occasionally we'll have failures, and we can learn from those failures. Everybody remembers little Philae going down to the surface of the comet and having a bit of an excursion. We've learned a lot from that, and hopefully that won't happen next time when we do something like this.
It inspired a lot of people. I know that from personal experience. Mark McCaughrean, as always, very good to have you on stage. Thank you very much.
Thanks very much.
Okay, I can tell you it's not long anymore until we should get the first signal. And it's just enough time for me to speak to another gentleman. His name is Carlo Cassi, and he's from Thales Alenia Space. That's the prime contractor of the ExoMars satellite. Carlo, good of you to come here. You come over from the project room, of course. You represent Thales Alenia Space. That's the industry behind the mission during the launch and the early flight. So you can tell us, where was the satellite built? How did it all come together?
I can. Okay, the overall spacecraft was built basically in 2 sites of Thales Alenia. The module, the landing module you have upstairs over my head, was built in Torino. And the trace gas orbiter, the big orbiter, which also carries the module to Mars, was built in the company premises in Cannes, in France.
Okay, but there were a lot of European and ESA members involved, a lot of different countries. Now we know when we look at Europe and the European Union, it's not always easy to get them all on the same page. How did you manage to do that?
Well, we managed. We had a lot of contents of contractors to do this big enterprise. I wish to remember the most important one from Germany, the OHB company doing the mechanical and thermal propulsion module of the orbiter. From France itself, the solar array, the big solar array, a lot of electronics were done in Sweden. We have a separation system between the module and the orbiter, which is done in Switzerland. And so. It was not easy, but we managed because I was saying before,
You had the
As
same
you
goal.
said, the engineers are the best politicians.
The engineers are the best politicians.
Because
with this line, I would like to release you because it can't get any better than this. Carlo Casti, thank you very much.
Thank you very much.
Thank you very much for being on stage.
Goodbye.
And of course, I'm moving on swiftly because we are nearing this crucial point, the moment of truth right now. The control team here at the European Space Operations Center is pointing the antenna to the sky in order to be ready to pick up the signal from ExoMars as it's passing on the horizon. This is, of course, also a moment eagerly awaited at the Russian Control Center ZUP in Moscow. And I believe we do have some live pictures of them standing there by and waiting. Yes, here they are, as excited and as nervous. And I even think this is our Director General there, Jan Werner. Yes, also very excited. Busy moment also for the ESA ExoMars Flight Director, Michel Denis. And this is why I'm not going to talk to him now. I will not disturb him. I'm very happy, though, to talk to the Deputy, Micha Schmidt. And if you remember, we spoke to him this morning already, and he's back with us again. Micha, good to see you. Micha, this is exciting, and it's brilliant that you still have nerves to speak to us. Let's talk about the acquisition of Signal AOS. What does it mean?
Well, it actually means that one of the automatic sequences on board of the spacecraft switches on its radio. So actually it starts transmitting a signal to the ground station, and I'm just looking here in the main control room on the display, and I will see that change reflected in one of the diagrams.
Okay, we could hear just the very end of what you said. I know we're waiting for the signal, but would you mind repeating that again, because we missed the rest. We did have a sound problem.
Okay, I hope it's getting better with the spacecraft. So what we are waiting for is that an automatic sequence on board will switch on the radio of the spacecraft, and then we would see the signal in one of our ground stations, which is Malindi. I'm looking at a display here in the main control room and would see this change reflected in the diagram.
Exactly. We've pointed at that screen already. How far away is ExoMars at the moment? Do we know?
Well, it's about 30,000 kilometers, and therefore actually Malindi, which is a 2-meter dish, is just suited for that. It's good. But we got a big boost. So actually we're going out fast, very fast, in the direction of Mars. And in about 2 hours, we need to switch to a bigger ground station. So we will pick one of our 50-meter dishes, which will be Maspalomas.
All right. What does this first signal exactly tell you when we get it?
Well, first of all, we see that the spacecraft is alive, as it should be, and then we can follow what is just going on in this very moment while these automatic sequences are ticking away. So one of the points would be that the radio is switched on, otherwise we wouldn't see the signal, but at the same time also we are going to deploy the solar arrays such that the power supply is being delivered. And that should happen around this time we get the signal, so we can follow this, and we can follow also the movement of the spacecraft being initiated by this.
All right, and I can tell everyone is getting a bit more nervous. It's on your fingertips. You want to see action now, which is why, Michael Schmidt, I will release you now. Thank you very much. We'll be quiet for a moment and watch and see what happens.
Thank you very much.
We are just waiting for the first telemetry to come in.
Yes.
as soon as the decoding, the signal is better. The signal is better. Yes, yes, yes. And, OM, can you give us telemetry? It's modulated. Yes. Yes. No. Very signal, very signal. The spacecraft is there, and it goes to Mars. So. Yes. We have a OS, we have a mission, and for the second time, Euros go to Mars. So go, ExoMars.
So, ExoMars is alive and kicking, wonderful, and everyone in Moscow at SUP has also witnessed that, and we are now connected on the phone with the ESA Director General Jan Werner. He joins us for a short statement, and we'd like to hear that now.
Yes, good evening to Darmstadt. It's Jan Werner. I'm really happy that we have this signal right now. So ESA and Roscosmos, we are on the way to Mars, and this is really a very nice experience to have this inspiring mission now realized, and let's go forward to Mars and see what we can do.
Indeed. Congratulations, and thank you very much, Jan Werner, ESA Director General. They're speaking to us from SUP in Moscow. Congratulations. And congratulations also to the team there in Moscow.
Yes, I would like to thank. I would also like thank you to all the teams here in Russia, but as well also in Kazakhstan, and also, of course, in Europe. They did a great job, industry and all the agencies together. Thank you very much.
Indeed. Thank you, everybody. I think this deserves a bit of applause because the people have really done a great job. And of course, we do have two gentlemen here with us who would also say a few things about this. I'd like to ask them on stage together. Rolf Densing, ESA's Director of Operations, and Mark McCaughrean, ESA Science Advisor. Please give us your statement.
Well, look, you know, we've been hanging out here all day long, and I'm only standing through the wonders, am I allowed to do this, of the wonders of Red Bull. Free cases, please. It's been just astonishing day, and to see it go flawlessly. I mean, everything's gone great. We saw the signal come in. Michelle, all of our flight directors, they're just amazingly cool guys, right? It's like, yeah, signal, we're on our way to Mars. Fantastic. Brilliant work by all the team, as the DG said. So go Mars, go ExoMars.
So this has been a long and exciting day. We have been in the hands of our Russian partners throughout the whole day. We've got reassuring evidence all through the day. But I'm really, really glad that we also got this acquisition of signal. And having been in the hands of our Russian partner, this time we have been in very good hands. So thank you very much to our partners from Roscosmos, also to the people present here representing Roscosmos. So I'm happy for the scientists. You've got a mission. I have great respect for what you have developed. And so I'm excited to follow this mission. So congratulations to everybody involved in this mission. And I'd like to point out on how proud I am on my own team here in ESOC. So it's up to you now to guide this mission to Mars, and good luck. Thank you.
Thank you very much, Rolf Densing. Thank you very much, Mark McCaughrean. I will keep it short and sweet now. Please do remember the next big step now is the 19th of October 2016. This is when ExoMars is scheduled for landing, so make sure it's already marked in your calendar. A big thank you to all the experts on stage, to the audience here, to everyone watching out there. Again, hello to Sup there, and well done. If you want to keep an eye on what's happening with ExoMars in the coming weeks and months, then do check with the ESA website. That is www.esa.int, and also follow us on social media, Twitter, Facebook, and everything else that exists by now. This is it from the evening program. My name is Monica Jones, and thank you so much again for letting me be part of this. I wish you now a pleasant remaining evening, a safe journey home, and yes, hopefully see you all again in autumn, October 19th. Bye-bye.
Есть двигателей первой ступени.